Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to EV Components Review, where I show off teardowns of various and sundry controllers and other EV-related electronics. So we're looking at the EBMX X-9000 power stage. I know a lot of this has been seen before, but this is specifically the electronics and not really the power buses per se. So anyway, you're looking at the F015N10 MOSFET, and that is a component made by a company called Huayi, something like that. Sorry guys, I don't speak the language, so I'm going to pronunciate all that stuff really badly. It is a Chinese MOSFET, but talking to electrical engineers, which I do, I know quite a few of them. I have access to the full VEST development folks, and there's a bunch of people that will answer your questions, and so I ask questions. And, well, they like these MOSFETs. They think they're pretty decent, so I can only go with what they say, that, yeah, this is a Chinese MOSFET that's pretty good. There's a bunch of controllers like Schul that use them. FlipSky uses this MOSFET. KO Moto uses this MOSFET. A couple other ones I've run into use it as well. So, yeah, it's a well-known component, and it's reasonably well-liked. I am very biased towards my Western components, so yeah, I definitely like Western parts, but yeah, people that are actual electrical engineers that build around this stuff, they use these guys with a great deal of confidence. So all I can say is, all right, you guys know better than I do, and I will take your word for it. So I've mentioned this already. So this is the gate leg on the MOSFETs, and you've got a tiny resistor and capacitor on each one. Again, I talked to some electrical engineers about this. Everybody knows that this is like the best way to do your MOSFET drive circuitry. You don't have to do this, not really. You could take all 5 of those MOSFETs and drive them off a single resistor and a single capacitor and be okay, and a lot of guys out there do that. But, you know, ideally, the best way to do it is what you see here. So this is really good, and it's not, you know, strictly critical that you do it, but, you know, here it is. The EBMX engineers did it. So all I can say is good job, you guys. You did something that was, you know, over the top. You know, it was better than anybody else does things. So I can't really fault that at all. The current paths are very short. You can't really get it much closer than this because, you know, here's the copper bus bar, and then you've got the small gap where you've got just the circuit board traces, which is one broad piece all the way across here to the MOSFETs, and then you have another little gap right here before you get to the phase bus. But again, you can't really avoid a lot of this. I guess you could put the MOSFET right up next to it, but you couldn't do that on the other side because you have gate and components and things like that that have to be right here. That would create some amount of gap. So could it be a little bit tighter? Yes, but is it really going to make that much difference? Not really. This is still a very excellent current path. Not tortured in any way. I've already shown this before. So here's 2 of your thermistors for the center phase, and this is the rightmost phase. And here they are, 1 per phase. So that's all very good too. Not much else to really show here. Let me get this out of the way. You are blocking me from sliding around. There we go. So down on this end, we've got a couple of ceramic capacitors. I have mentioned that I wish there was 4 of them here rather than 2. That's something that's fairly easy to fix because the traces are right here. It's just a matter of extending them a little bit further this way and this way, so you can add a couple more of these ceramic caps, and that would help a little bit with noise control. I don't know how much is really here because I haven't looked at any of this stuff on an oscilloscope to know as a fact, but more is generally better, so I always like to see more. I would also like to see some in here, and now that you can see right up close, you can see that spider leg work of traces all around this connector, and as you can see, there is no way. Up here is battery plus, and down here is battery minus. There's no way to get a thick trace through here anywhere to be able to put some more ceramic caps in this area so you can have them between the phases. So yeah, it's essentially impossible to do what I had asked for in the other video, which was try to get some ceramic caps like right in these areas. And the same thing is true over on this one too. You can see the spider leg of small traces in there. Yeah, there we go. You can really see them now. yeah, there's no way to get some large traces in there so that you can put battery plus and battery minus down there and a few ceramic caps to filter right in this area. It's just simply not possible. So they did the best they could, and they put them down on the ends. So it is what it is. There's not much you can do about it. So let's flip this around. Okay, right between battery plus and battery minus. So this right here, that is battery minus, and this one up here, that's battery plus right here. And then they've got 4 ceramic caps in there for more high frequency filtering. And as you can see, there is a copper path that starts right there, goes all the way over to there, and it's literally across that entire width. And pretty much all it's doing is going over to those 4 capacitors. So that's a lot of copper there. I mean, it's cool that it's there, but yeah, that's a lot of copper for just doing high frequency filtering. So, you know, good for you, EBMX. That's awesome. You didn't have to do that. And truthfully, this was a situation where it didn't really matter. They could have etched off the copper, but why? Just leave it there. It's not harming anything. So that's really the reason for that. There was no, like, you know, that was a really awesome design. It was just simply a case of, we don't need to etch it off, so leave it. All right. The last thing I want to show you, and you just saw this in my previous video, is those two guys. And so that's a Schottky diode, you know, a high frequency diode. And this is the MOSFET for the 5 amp 12 volt DC to DC converter for external peripherals, like say a water pump or whatever that is on the controller. So anyway, that's pretty much everything that's here on the power stage. This is a really excellent power stage. This is a really excellent power stage. I mean, massive copper bars. You know, solid copper everywhere here. This is awesome. All right, so before I stop this video, I want to show the other one because some people had asked me about something, and so I thought I would show it. Okay, let's see if I can get the camera to cooperate with me. Yeah, there we go. So you can see that gap, that crack in there, and the vertical cylinder is press fit into the flat copper bar, and then there is an M6 screw in the bottom that screws the two together. So they're not coming apart. Anyway, somebody that was a machinist was asking me, are you sure those were a single piece of copper that were machined as one part? And in the other board, they sure look like it, because there's no little gap in there to see. But in this one, you know, the fit and finish isn't quite the same, and as a result, you can see that gap in there. So yeah, it is actually 2 parts. And now I know it is for a fact, and in fact, you can't see it, but down inside that black hole down there, I can see the end of a screw, and that's coming up through that, you know, horizontal piece of solid copper and going up to the into the standoff. The other thing I wanted to show is, yeah, where's that spot where I scraped off? There it is, over there. So again, this is a production unit. This isn't a pre-production unit like the other power stages, and yeah, right there. So that little spot right there. Yeah, you can see the golden color in there. That's copper. Yeah, so the rumor that there was possibly brass or something like that, or aluminum, or who knows, that was going to get used. Yep. Sorry guys, that's copper. And in fact, let's do the little bridge section 2. So here is where the 3-phase wires come in, and they go to those bridges, which bolt down right here. And on the center one, yeah, I cut a little piece of the plating off of there. You can see that nice golden color in there. Again, it's solid copper. You know, they didn't do anything other than solid copper, and then they plated it all so that it would not oxidize. So, yeah, just super good attention to detail, super high quality, no corners cut anywhere in these controllers. How somebody could hate on EBMX is an absolute mystery to me, because they did an awesome job in every possible way. I gotta say, I had no idea what I was going to find when I got an EBMX, other than what I was looking at in pictures. And then when I got it in my hands and I started looking and looking and looking, all I could say is I just fell in love with them, because they're really good design work. I love good engineering, and well, this is good engineering. So anybody who thinks I'm a KO fanboy, or or I'm sorry, a EBMX fanboy, or I'm some other sponsored, you don't get it. This is good engineering. That's what I like about it. Yeah, good engineering. Lots of quality stuff in here. Well, I hope that helps some folks out. Yeah, this has been a fun teardown, and it's not over yet. This has been a fun teardown. I have really enjoyed looking into the X-9000 controller because there is so much good stuff going on in here that I don't see in other controllers. So yeah, really happy about how this controller is designed, how it's laid out. Yeah, this is a highly resilient controller. Yep. Hope that helps some folks out. Talk to you all later. Enjoy.